welcome to the Journey Chez Chem. Well, today we have some more practice, so please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. Number 1, we are given 0.75 molar as my concentration. And whenever I am given a concentration, I always define it. What this means is that I have 0.75 moles of my solute, which in this case is cadmium hypochlorite, per 1 liter of solution. Now, I want to make the solution, but I don't want to make a liter of it. I want to make a different amount. Therefore, I need to know the number of moles for my different volume. And I am given 750 milliliters. And therefore, I must change it to liters. And this value then is 0.75 liters. Because I have liters here, I must have liters here. Then I just cross multiply. And when I cross multiply these two numbers, then X is equal to 0.5625 moles of my cadmium hypochlorite. And then I change my moles to grams. Well, I have 0.5625 moles. Now, it is very important that we write the equation or the formula for cadmium hypochlorite correctly. And you might need to refer to your penguin. Well, cadmium has a charge, oh, that's calcium. Cadmium has a charge of +2, and hypochlorite is -1. And therefore, I need 2 hypochlorites. And I'm going to erase this. And then, to change my moles to grams, I have to add up the AMUs of the cadmium hypochlorite. Well, I have 2 cadmium, or 1 cadmium. I have cadmium, and when I look at the periodic chart, I see that its mass is 112.4 AMU, or grams per mole. There are 2 chlorines, and each chlorine has a mass of 35.5. And there are 2 oxygens, and each oxygen is 16.0. And you know I write them again, so I have 1, I'm going to write them a little bit lower here, 112.4, 71.0, and 32.0. And I add them up again, and I get 215.4 grams per mole is my AMU, my molecular weight, my formula weight. And I'm looking for grams, so my mass goes in the top. And that is 1 mole of the cadmium hypochlorite. And then I'm going to erase this portion. I believe that you're very good at finding the formula masses now. However, I do review them every time. Well, when I do this math, I come out with 121.1625. I look back to my original numbers, and the least number of significant digits given in the problem are 2. And therefore, this 1 does not round this 2 up, and my final answer is 120 grams of cadmium hypochlorite are added to a total volume of 0.75 liters, or 750 milliliters. I would have a volumetric flask that would have exactly 750 milliliters marked on it. And that is how I do number 1. In number 2, we are determining the number of iron and chromate ions in a solution. But first we have to determine the molarity of the solution. And we are given 59.6 grams of the iron 3 chromate. Now iron has a charge of +3, and that's what the Roman numeral is telling us. Chromate is -2, and therefore the common multiple between 3 and 2 is 6. So I need 2 irons to get +6 and 2 chromates to get -6. And +6 is -6 is 0. Now I have to change my grams to moles because I'm looking for molarity, which is moles of solute per liter of solution. And therefore, I must get the atomic mass or the molecular weight or formula weight for the iron 3 chromate. Well, there are 2 irons, and each iron has a mass of 55.9 AMU. There are 3 chromiums, and therefore each chromium is 52.0. And there are 12 oxygens, which is 12 times 16.0. You know I write them again, and therefore I get 111.8 and 156.0 and 192.0. And I add them together and I get a total mass of 459.8 grams per mole, and therefore that is my conversion factor. I want to find moles, therefore they go in the top. And I want to cancel my grams, and therefore it goes in the bottom. And that gives me 0.1294 moles of the iron 3 chromate. And then to get molarity, I must divide it by the volume of the solution. And in this problem, we were given 950 milliliters. And therefore, I'm going to change my 950 milliliters to liters. And that would be 0.95 liters. Molarity is moles per liter of solution. And then when I get this number, I'm going to get 0.1364, and I want 2 significant digits. And even though this is not my final answer, it is the answer that I will be using to do the other work. And therefore, this 6 rounds the 3 up, and I get 0.14 molar of the iron 3 chromate. That iron 3 just throws me off there. And now I'm going to use that to determine the number of ions. And this is going to become very important in the next topic as well. Well, iron 3 chromate is a salt. And all salts are strong electrolytes, except for the mercury salts as far as we're concerned, and that would mean that they would have 100% dissociation. And therefore I get 2 iron ions and 3 chromate ions in the solution. And I have 0.14 molar of my original solution. And then I multiply by 2 in order to get the iron ions. And therefore it would be 0.28 molar of the iron ions and 3 times the amount, or 0.42 molar of the chromate ions. Now it would be possible also to show the conversion factor. I have the molarity of the chromate solution, and then I use the mole ratio. And there are 2 moles of iron ions to every 1 mole of the original iron 3 chromate. And then that would give me this 0.28 molar. Now, this is going to become very, very important in the future, and it's very important that we understand that when you have one of these salt particles, that it dissociates 100% to give me the ions. It's just like when I have one car, I have a variety of different parts, and when I break the parts into individual parts, I get more of them than I had as just one car. And that's number 2. Tomorrow, we are starting a 3-day lab. Now, this lab is designed to go straight through in 2.5 hours, but in a normal school day, we don't have 2.5 hours, and therefore it's broken up into 3 different days. And tomorrow, we're going to start the first day. However, you need to write up the procedure for the complete lab so you have some idea of what's going on for those 3 days. And on the very front are 5 reactions, and those are the 5 reactions that we are going to do. Tomorrow, we will do the first 3 reactions, And then we will do, the second day, we will do the final 2 reactions, and the third day we just clean up that final copper. Well, I'm so excited, and I can't wait to see you tomorrow. Bye.